JEE Advanced mock test questions. So mock test questions means these questions are from your PYQs, and these PYQs are recent year, not your 2004, 2003, those type of PYQs. It's a recent year PYQs like your 2019, 2020, 2021. So the first question is, let m be the minimum possible value of log to the base 3 of 3 power y1 plus 3 power y2 plus 3 power y3, where y1, y2, y3 are real numbers for which y1 plus y2 plus y3 is equal to 9. Let capital M be the maximum value of log to the base 3 of x1 plus log to the base 3 of x2 plus log to the base 3 of x3, where x1, x2, x3 are positive real numbers for which x1 plus x2 plus x3 is equal to 9. Then find the value of log to the base 2 of m cube plus log to the base 3 of capital M square. Such a big question, now. It's a very big question, but guys, the methodology that I'm going to use will make you people mind blown away, because you can't express logarithm question in JEE Advanced. Many people think like that. What they will think is in JEE Advanced they don't have logarithm question because those are simple tasks, simple properties. So why do they need to ask in JEE Advanced? That's the mindset of every people. But expect the unexpected one. Expect the unexpected one. This is a JEE Advanced 2020 question. Okay? They're asking it. So you should be aware of it and you should be ready for it. That is what I want to conclude from that. I'm not coming here to just solve this question, and also want to say the main meaning. What I want to convey is you can expect the unexpected one. That is what I want to conclude from this question. Okay? So let's start to solve, people. So they gave that your small m is the minimum possible value of this expression. So whenever you hear the minimum possible value, what comes to your mind is your AMG inequality, correct now? That's what will come to your mind whenever you hear the word minimum possible value. And also it is the question is given that y1, y2, y3 are real numbers. From this itself you will make sure that we are going to use your AMGM inequality. Because for AMGM inequality, terms must be real numbers, and whenever they ask the minimum value, that is where you will be using the AMGM inequality. So let me use your AMGM inequality. So using AM greater than or equal to GM inequality, I am going to solve the first part of the question. First part means they gave that small m is the minimum possible value now. So for that expression I am going to solve using your AMGM inequality. So the question is given that y1, y2, y3 are real numbers. Then of course your 3 power y1 plus 3 power y2 and 3 power y3 will also be a positive real number, correct now? If y1, y2, y3 are real numbers, I mean the positive numbers, then of course log to the base 3 of 3 power y1 plus 3 power y2 plus 3 power y3 will also be a real number, correct na? Correct na? So that's what I can conclude from here. So now what you are going to do here is, using your AMGM inequality, what I will say is, let me take the terms as 3 power y1 plus 3 power y2 plus 3 power y3 divided by 3, because the total number of terms are 3 here, will be greater than or equal to the GM of the 3 terms. Geometric properties of 3 terms will be 3 power y1 into 3 power y2 into 3 power y3 whole power 1 by 3. That means your cube root, correct na? Using your AMGM inequality, I can say that the AMGM your AM will be 3 power y1 plus 3 power y2 plus 3 power y3 by 3 will be greater than or equal to 3 power y1 into 3 power y2 into 3 power y3 whole power 1 by 3. This is the AMGM inequality form of expression that I wrote, and the terms that I took are 3 power y1, 3 power y2 and 3 power y3. Okay, that's all. So now people take this 3 to that side, so therefore I can write the same expression as 3 power y1 plus 3 power y2 plus 3 power y3 will be greater than or equal to 3 into 3 power y1 into 3 power y2 into 3 power y3. whole power 1 by 3. That is something I will get now. Correct now. I take 3 to this side. This is the form of expression. This is the form of expression that you guys will be left out. Okay. So I will take the tester. I will wrap this up. Okay. This is the form of expression will be left out. But the thing is, in the question, every form of expression is in the term of log to the base 3. So what I'm going to do here is, in this inequality, I'm going to take log to the base 3 on both sides of the expression. I'm going to take a log to the base 3 on both sides of the expression. I will get the same expression as log to the base 3 of 3 power y1 plus 3 power y2 plus 3 power y3 will be greater than or equal to, when I take log on your this side, log to the base 3 on this side, listen very carefully, I am having 3 into this expression. 3 into this expression, so that I can write this as log to the base 3 of 3. Correct now? Listen very carefully. This is one term, that is your 3, and this is one term. So log to the base a of ab can be written as, that means log to the base m of ab can be written as log to the base m of a plus log to the base m of b, and that's the property I'm going to use here. Therefore, I can write this log to the base 3 of 3 power y1 plus 3 power y3. Sorry. It will be product now. Sorry people, it is product. So 3 power y1 into 3 power y2 into 3 power y3 whole power 1 by 3. Here also it is 3. Sorry, it is 3. Okay. So because a big question, guys, you should be very careful upon the variables. If you do a single mistake, then that will lead to a very different answer. Okay. So now people, what I will get is log to the base 3 of 3 power y1 plus 3 power y2 plus 3 power y3 will be greater than or equal to, listen, log to the base 3 of 3 will be nothing but 1, because log to the base a of a is 1. Then plus of, listen, I am having product in it, therefore I can write this as log to the base 3 of 3 power y1 log to the base 3 plus 3 power y2 log to the base 3 plus 3 power y3 properties. Can't I write that? Listen carefully. I can write the same expression log to the base 3 of 3 power y1 plus log to the base 3 of 3 power y2 plus log to the base 3 of 3 power y3. Correct now? Can I write like this? Think carefully and say log properties. Hence log to the base 3 of 3 power y1 will be y1 only. Log to the base 3 of 3 power y2 will be y2. Then log to the base 3 of 3 power y3 will be y3. Simple things now. Simple properties. Now, do we know the value of y1 plus y2 plus y3? Of course, yes. It is given as 9. Correct or not? Think carefully and say. And people, we are having 1 by 3 on the power. Hence, I should write this as 1 by 3 into this value. Again properties. I am having power of 1 by 3. Hence, I can take the 1 by 3 outside. That's also a property. For example, log to the base a of m power n can be written as n into log to the base a of m. This is one property. Okay, using this property only I am saying log to the base a of m power n is n into log to the base of m. Here your n is 1 by 3. That's why you took this 1 by 3 outside. Hence, using this particular expression, like I write this 1 by y1 plus y2 plus y3. That's all. I hope you guys can understand whatever I am doing here, because people, this is a JEE advanced question, and I want you guys to be aware of all such things. Okay. Now, do we know the value of y1 plus y2 plus y3? Of course, yes. So that is your 9. So 1 by 3 into 9 will be what? 1 by 3 into 9 will be 3. So 3 plus 1 will be 4. So hence I found that your log to the base 3 of 3 power y1 plus 3 power y2 plus 3 power y3 will be greater than or equal to 4. Correct now? Hence, in the question it is given that m is the minimum possible value of this expression. This expression are same. This expression are same. Hence, I will say that your minimum value, it is your minimum possible value, m is nothing but your 4. Correct, no? Such a beautiful thing, guys. So you have found your small m as 4. Because in the question is given as m is the minimum possible value of this expression. So we know this expression is greater than or equal to 4. Hence your capital M will be, your small m will be 4. Now let us go on to the second part of the question. So your second part of the question is your maximum value of log to the base 3 of x1 plus log to the base 3 of x2 plus log to the base 3 of x3, where x1, x2, x4 are positive real numbers for which x1 plus x2 plus x3 are 9. Here, the term that I am going to consider is x1 plus x2, x3. So here also I am going to use your AMGM inequality. So using AMGM inequality, I will say that x1, x1 plus x2 plus x3 by 3 will be greater than or equal to x1 into x2 into x3 whole power 1 by 3. Correct now? Using AMGM inequality, I am saying the term that I am considering here is x1, x2, x3. Okay? So using AMGM inequality, this is the form of expression I will be left out. Now take log to the base 3 on both sides, because here also I am having log to the base 3 on every term. So when I take log to the base 3 on both sides, I will get log to the base 3 of what is x1 plus x2 plus x3? That is given as 9. So 9 by 3 will be 3. Then that will be greater than or equal to, when I take log on this side, log of x1 into x2 into x3 whole power 1 by 3. That 1 by 3 I can take outside. So 1 by 3 into log of x1 into x2 into x3. Correct now? This is something will be left out. I hope that makes you people very here log to the base 3. So 1 by 3, that power I am taking outside, that's one of the property. Recently I told, right, that's the property I am using here. Hence log to the base 3 of 3 is 1. Log to the base 3 of A is 1 of greater than or equal to 1 by 3 of log to the base 3 of x1 into x2 into x3 can be written as log to the base 3 of x1 plus log to the base 3 log to the base 3 of x2 plus log to the base 3 of x3. Correct na? Correct na? Again properties. Very simple people. Again I am using properties. This is a very good question. Okay, advanced means you can't just expect the lollu questions. Easy questions. So you should be very aware of these properties, because as I am multiplication, I can make it into sum. That is what I did here. Now I can take this 3 to this side, hence I will get 3 is greater than or equal to log to the base 3 of x1 plus log to the base 3 of x2 plus log to the base 3 of x3. Correct now? This is what I will be left out finally. So now in the question is given that the maximum possibility of this expression, that means this expression are same, and is given that the maximum possible value is capital M. Let M be the maximum possible value, that means 3 is your capital M. Correct now? See, just now only we found the capital M. So the level of question is incredible, people. Level of question is incredible. So they are given M is the maximum possible value. We know that 3 is greater than or equal to this expression, hence the maximum value of this expression will be 3. So now what is being asked in the question is, log to the base 2 of m cube. That is log to the base 2 of m cube will be what? That is your small m cube, that will be 4 cube plus of log to the base 3. Log to the base 3 of m square will be, just your capital M square, that will be 3 square. So now that take the 3 outside, will get log to the base 2 of 4 plus take this 2 again outside, will get log to the base 3 of 3. Correct? So finally we'll get 3 into log to the base 2 of 4. So 2 part something will give us 4, that something will be 2, because 2 square only will give us 4. So that's why your power is 2 plus of 2 into log to the base 3 of 3 will be 1 only. So this will give us 3 into 2 6, so 6 plus 2 is 8, and that's the answer for the question. Beautiful question, guys. Very good question. This is a beautiful question. I liked it a lot. And the answer is 8. That's all, guys. Let us move on to the next one. Next question is, for any positive integer n, let Sn, they gave some relation, and that is defined by Sn of x is equal to summation of coterms of 1 plus k into k plus 1 x square by x from k is equal to 1 to n, where for any x belongs to real number, coterms of x belongs to 0 to pi and tans of x belongs to minus pi by 2 to pi by 2, then which of the following statement is or true? Is or true? Okay. So more than one can be correct for this particular question. The first option is S10 of x is equal to pi by 2 minus tans of 1 plus 11x square by 10x square for all x is greater than 0, and your second option is limit of n tends to infinity of cot of Sn of x is equal to x for all x greater than 0, and the third option is the equation, guys, this is the equation S3 of x is equal to pi by 4 has root in 0 to infinity, and your fourth option is tan of Sn of x is less than or equal to 1 by 2 for all n is greater than or equal to 1 and x greater than 0. So people, how will you solve this? How will you first approach this question? Do you guys have any idea? Okay, first let's start from the first option. Actually in the question is given that Sn of x is this summation. So even in JEE means you would have solved the question like this, not this much tough level, but the basic things like inverse trigonometry summation problem, right? You would have solved that. In JEE Advanced, they ask that problem in a different method, but the things that you are going to do are the same. They ask in different method, but the things that you are going to do is the same as usual you do in your JEE mains. So what you do is, whenever a particular summation or any series is given, the first thing that you will do is you will convert it to tan inverse, and that is what I am going to do here also. Okay, that is what I am going to do here also. So this same Sn of x, I will write here people, this same Sn of x can be written as, listen, summation of, so k is equal to 1 to n only, 1 to n. Now, it is cot inverse of 1 plus k into k plus 1 of x square by x. I am going to write this cot inverse in terms of tan inverse. So, when I write it in terms of tan inverse, I will get it as just your instead expression will get reciprocated. So, tan inverse of x by 1 plus k into k plus 1 into x square, correct? This is what I will be left out with. Okay. So this is the form of expression that you guys will get when you convert this cot inverse in terms of tan inverse. So now people, what you will do is very simple. You are going to use that tans of a minus tans of b formula. Tans of a minus tans of b is tans of a minus b to 1 plus ab. And that is the form of expression I am going to use here, because I need to convert this as tan inverse of a minus b divided by 1 plus ab. So what I am going to do is, can't I write this x as, listen carefully, observe it, can't I write this x as k plus 1 into x minus kx? Think carefully and say, can't I write the x as k plus 1 into x minus kx? Very simple. I can write like that. Such simple concept, na? You guys are must aware of it. The basic things, the basic methodology. I'm just writing this x as k plus 1 of x minus kx. Anyway, it will give us x. But the reason we can doing this is, in order to make this particular form as tans of a, that is your k plus 1 of x, minus b, that is your k, x will be 1 plus ab. Same now. Because k plus 1 into x into kx will give us k into k plus 1 into x square. That's all. That's all. I'm just making it to that form. So now, for the first option, what is given is, it is given as S10 of x. So S10 of x will be, just put this n as 10, okay. When you put this n as 10, S10 of x will be summation of k is equal to 1 to 10, correct? Correct? Think carefully and say, if you need to find the value S10 of x, just put your n as 10 now. So now people, I can write the same summation as, listen very carefully, summation of k is equal to 1 to 10 only. Now, using that formula, I can write the tan inverse of a minus b. That is tan inverse of k plus 1 of x minus tan inverse of kx. Correct? I don't have space. I don't know what to do. I can write this as tan inverse of kx. This is what I am left out. Okay, guys, I hope you guys can understand what I am trying to say here. I am just using your tans of a minus tans of b is tans of a minus b 1 plus ab. So using that, I can write the tan inverse of a minus tans of b. That will be tans of k plus 1x minus tans of kx. That's all. Very simple, na? I hope you guys can understand whatever methodology I am trying to say here now. Okay. So as your summations from k is equal to 1 to 10, I can write this value as tan inverse of k plus 1x will be tan inverse of 11x minus tan inverse of kx will be tans of x. Just solve it up, people. I can't solve it because it's JEE advanced question and I don't even have space, right? So just solve it up, put a ks1, ks2, ks3 all the way up to 10. Most of the terms will get cancelled and you'll be left out with these two terms. Okay, very simple. So now tans of 11x minus tans of x is what? Again use tans of a and tans of b, that is tan inverse of a minus b by 1 plus ab. So tans of 11x minus x is 10x here. By 1 plus ab will be 1 plus a into b. 1 plus a into b is 1 plus 11x square. Correct? Correct? Think carefully and say. So now you know one thing, na? You know this is the value of S10 of x. So S10 is equal to tan inverse of 10x by 1 plus 11x square. So S10 of x is, so S10 means S10 of x only. Don't misunderstood. Don't misunderstand. That is tans of 10x by 1 plus 11x square. Now I will rub this, people. I don't think so. You guys need this now. So hence I will rub. No space I'm having. So anyway, you guys can understand, I hope. So this is your S10. So now I can write the same S10 now. Listen very carefully. Using one property of inverse trigonometric function, I can write this as pi by 2 minus cot inverse of 1 plus 11x, sorry, not 1 plus 11x square, 10x by 1 plus 11x square. You know this property, na? So tans of a plus cotans of a is pi by 2. That means tans of something plus cotans of the same thing will give us pi by 2. From that, I can write this extend this tans of 10x by 1 plus x square as pi by 2 minus cotans of the same thing. Properties, very important. So now this cotans of 10x by 1 plus 11x square can be written as 1 plus 11x by 10x, and that is what is given in option A. Hence your option is correct. So what I am saying is, I am having this now, so I can write the same S10 of x is pi by 2 minus cotans of 10x by 1 plus 11x square can be written as tan inverse, just reciprocated, hence you will get 1 plus 11x square by 10x. Correct? So this is your S10 of x, and that is what is given in option A. S10 of x is pi by 2 minus tan inverse of 1 plus 11x square by x by 10x, and I hope you guys see whatever I am trying to do here. So that's how your option A is correct. Guys, I will repeat once again. I just solved the summation from k is equal to 1 to 10. Then what you will get is, you will get S10 of x is tan of 10x by 1 plus 11x square. I can write this as pi by 2 minus cotans of 10x by 1 plus 11x square. Therefore, that cotans when I convert to tan inverse, your option A is something I will get. Okay. So hence I found that your option A is correct. Now I will rub all those things. I will rub all those things because we found that your option A is correct. Okay, wow. So now this is your S10 of x to n. This will give us your Sn of x. Sn of x is this summation. Okay, don't forget that. So let me keep this on one side. Sn of x will be summation of k is equal to 1 to n of Tans of k plus 1 of x minus tans of kx. So now, what is given next? Think carefully and say, what is given in second option is, it is given a limit of n tends to infinity cot of Sn of x. Cot of Sn of x is something given in the question. So people, this same Sn of x, can't I write this same Sn of x as, listen, can't I write the same Sn of x as tan inverse of, what you can write? Think carefully and say, can't I write the same Sn of x as tans of nx minus tans of x. Think carefully and say, I can write the same Sn of x as tans of nx minus tans of x. This particular property, not property, I am just writing the summation Sn of x is tans of nx minus x. I can write like that. Okay, because it is having from summation of k is equal to 1 to n number of elements. That is why I am writing like this. Okay, so I think what I am doing is correct now. I hope you guys can understand everything. So you may ask, yeah, I think it's correct. So now let me rub this up. Because we found out the value of Sn of x. So now in the question is given as limit of n, in your second option is given as limit of n tends to infinity cot of Sn of x. So now people, we know this is your Sn of x. It is given as limit of n tends to infinity cot of Sn of x. When your n tends to infinity, the same Sn of x will be nothing but listen, when your n tends to infinity, for tans of nx, when your n tends to infinity, it will be tans of infinity, that is your pi by 2. That's your pi by 2, correct na? Then you will get minus tans of x. I hope you guys can understand what I am trying to do here. I am having limit of n tends to infinity. As n tends to infinity, there is tans of nx. In this tans of nx, your n will tend to infinity. If your n tends to infinity, you will get tans of infinity, that is pi by 2 minus tans of x. Okay, so I was thinking to pi by 2 minus tans of x. Pi by 2 minus tans of x. So Sn of x can be written as pi by 2 minus tans of x is cotans of x. Correct? Property, because tans of x and cotans of x is equal to pi by 2, property of inverse trigonometry function. This is one of the important formula. So therefore Sn of x will be cotans of x. So if Sn of x is cotans of x, cot of Sn of x will be cot of cotans of x, that is x. So of course your option B is also correct. So now let us go on to the next one. Guys, this is not a very tough question. Don't feel it's a very tough question because it looks very scary or looks very big. It's such a easy one. So don't ever do like that. So for option B, what it is, when you put n as infinity, you will get pi by 2 minus tans of x. That is your cotans of x. So cot of cotans of x will be x. So then of course your option B is correct. Now let us move on to the second one. How will you solve this? How will you solve the C option, people? How can you do that? Any idea? It is given S of 3 of x. S3 of x. So I think this will be n plus 1, okay? This will be n plus 1. Wait. N plus 1 into x, correct? N plus 1 into x. This S10 of x will be n plus 1 into x. N plus 1 into x. So hence S3 of x will be, I will write here. S3 of x will be nothing but, just put your n as 3. So therefore you get tans of 4x minus tans of, when you put minus tans of x, correct? This is what you will be left out. So now tans of a and tans of b is tans of a minus b, that will be tans of 4x minus x, that will be 3x by 1 plus ab, will be 1 plus 4x into x, that will be 1 plus 4x here. This will be your value of S3 of x, that is your tan inverse of 3x divided by 1 plus 4x square, and the question is given as S3 of x is pi by 4. That means pi by 4 I can write this as tan inverse of 1, correct? Guys, I hope you guys understand what I am doing here. S3 of x is tans of 3x by 1 plus 4x square, and I know that your pi by 4 can be written as tans of 1. So when I equate these two expressions, I will get your 3x by 1 plus 4x square is equal to 1, correct? Correct or not? Think carefully and say, if 3x by 1 plus 4x square is equal to 1, then the form of equation that will be left out is, 3x Wait people, I'm doing what I'm doing is correct now. So yeah, correct. So therefore I will be left out with 4x square minus 3x plus 1 will be equal to 0. This is the form of equation that will be left out. Very simple now. When you equate these two inverse trigonometry functions, these two tan inverse, I will get 3x by 1 plus 4x is equal to 1. Just cross multiply, therefore I will get 3x is equal to 1 plus 4x square. If 3x is equal to 1 plus 4x square, take the 3x to RHS and therefore I will get 4x square minus 3x plus 1 is equal to 0. And in the options it is given that the equation S3 of x is equal to pi by 4 has root in 0 to infinity. What does that mean? What does it mean is this is a positive, 0 to infinity positive value, positive direction it's going. But in this equation we know that this equation is an imaginary root. This equation is an imaginary root because the discriminant for this equation is less than 0. Think carefully and say. Your thinking capability is very important to solve such questions. Here it is given this S3 of x is equal to pi by 4 has root in 0 to infinity, but we know this for this S3 of x. This is S3 of x. This is S3 of x. So this S3 of x, that means this equation 4x square minus 3x plus 1 is equal to 0 has an imaginary root because your discriminant is less than 0. Just solve it. The discriminant is b square minus 4ac. When you find b square minus 4ac, that will be less than 0. If the discriminant is negative, then your roots are imaginary. The roots are imaginary, then of course your option C is wrong. See how I am solving. The methodology I am using here. Okay. This equation has an imaginary root, hence your option C can't have root in 0 to infinity. If it is imaginary, then how come it can be from 0 to infinity? Think. Okay, think. That's all. Hence your option C is wrong. So now I will wrap this up. So your final option is what we are having. I think your final option will also be wrong. So let me say how it is. Let me say how it is. It is given tan of Sn of x is less than or equal to 1 by 2 for all n is greater than or equal to 1 or x greater than 0. So therefore, say me one thing. Can't I write the same Sn of x as what you can write? Can't I write the same Sn of x as tan inverse of Can't I write like this, people? Think carefully and say, can't I do this? Of course I can do this because your Sn of x is tan of n plus 1x minus tan of nx. Hence tan of a and tan of b is tan of a minus b divided by 1 plus ab. Correct now? Tan inverse of a minus b divided by 1 plus ab. I can use that formula. I hope that makes you people clear. That will be n plus 1x minus x. Therefore, this is what you will be left out. So numerator will get nx divided by 1 plus ab will be 1 plus n plus 1x into x. That will be n plus 1 into x square. This will be your Sn of x. So now in the question is given that tan of Sn of x. Tan of Sn of x means take tan on both sides. Therefore this tan and this tan will get cancelled. Therefore I will get tan of Sn of x will be equal to, when you take tan on this side, when you take tan on this side, you will get nx by 1 plus n plus 1 into x square. Correct? This will be your tan of Sn of x. Because Sn of x is this expression means, then your tan of Sn of x will be tan of tan inverse. Therefore tan and tan inverse will cancel. This is something will be left out. So now in the question is less than or equal to 1 by 2. Do you think this expression will be always less than or equal to 1 by 2? Do you think so? Do you hope so? Will this expression will be always less than or equal to 1 by 2? Of course not. For example, they gave that n is greater than or equal to 1. So let me take your n as infinity. When you take your n as infinity, this tan of Sn of x will be, for example, when your n tends to infinity, then your tan of Sn of x will be what? That will be n infinity into x by 1 plus infinity plus 1 into x square. This will give us 1 by x. This will give us 1 by x. Correct na guys? Listen very carefully. We know tan of S1 of x is this expression and they gave that n is greater than or equal to 1. So let me take your n as infinity. Let me take that infinity so that I can prove the exception. When your n tends to infinity, this tan of S1 of x will be 1 by x. If it is 1 by x and is given as x is greater than 0, so let me take your x as 1. When you take x as 1, I'll get 1 by 1. 1 by 1 is 1 and 1 is 1 less than or equal to 1 by 2? No. When I take your x as 2, I'll get 1 by 2. So 1 by 2 is equal to 1 by 2 only. No problem. When I take 1 by 3, again it's okay. But when you put your x as 1, there is a problem. Because it is given as x is greater than 0. When you put your x as 1, you will get 1 by 1. 1 by 1 is 1, which is not even less than 1 by 2. So therefore your option D is also wrong, and that's how you should solve this. What a beautiful question. Guys. That's all. So option A and B are only good, C and D are wrong. That's all. Let us move on to the next one. The question is, the value of log to the base 2 of 9 whole square whole to the power 1 by log to the base 2 of log to the base 2 of 9 into root 7 to the power of 1 by log to the base 4 of 7. Guys, this looks complicated, but it's a very easy one. It's a very easy question, and this was asked in JEE Advanced 2018. But don't think that as I said, easy. Oh, it's a lollu question, man. I can solve in just 3 to 5 seconds. Don't think like that. If you know log properties only, you can solve this up. If you know log properties, you can solve. But many people know that. From 10th standard, you guys are learning now. Even from in these days, you are 7th, 6th standard people are not knowing logarithm properties. So they are also having the capability to solve this. But don't think it's a very easy one. You should know the log properties. If you think it's a very easy one, see where it is asked. Then only you will regret that, oh, it was asked in JEE Advanced 2018. That means it will be tough now. Like that you will be thinking. So people, how are you going to solve these questions? It's a very easy one. Try to observe the expression given here. What I'm going to do here is, I am having log to the base 2 of 9. I am going to use your laws of exponents. That is your a power m. I will explain from your scratch, okay? So a power m whole power n is a power m into n. Correct now? This is property you know, right? So from that I can write this as log to the base 2 of 9. That will be 2 into 1 by log to the base 2 of log to the base 2 of 9. Think very carefully. 1 by log to the base b of a can be written as log to the base a of b. Correct now? Your log, your base and your inside value just reverse. 1 by log to the base b of a is log to the base a of b. Hence I can write this as log to the base 2 of 9 of 2. Guys, you may think what this guy is saying. Log to the base 2 of 9 of 2. What is this guy saying? People, that is what is given in the question. Don't criticize me. Actually, I am doing whatever the methodology. Okay, this is how you should pronounce, so that is what I am doing. Some people pronounce base after the inside value, but I am pronouncing base before the inside value. It's your methodology. My convenient way is like this. Your convenient way will be different, so that's not at all a problem. So 1 by log to the base b of a can be written as log to the base a of b. Hence, I can write this as log to the base 2 of 9 whole power 2 into 1 by log to the base 2 of log to the base 2 of 9. Hence, I can write this 1 by log to the base 2 of log to the base 2 of 9 as this log to the base 2 of 9 will become base and 2 will become inside value. That is what I wrote here. So log to the base 2 of 9 of 2. This 2 is inside value. Don't think it's the power. This is inside value. Okay. Now, then I am having into root 7. Root 7 is 7 power 1 by 2. So 7 power 1 by 2 into, again the same property. This will be log to the base 7 of 4. Correct? Just inverting your base and your inside value. 1 by log to the base a of b is log to the base a of b. Hence, now listen very carefully. 2 into log to the base log to the base 2 of 9 of 2. This is what I am having, right? So listen, I can write this as log to the base 2 of 9. So you know this now. N into log to the base A of m can be written as log to the base A of m power n. Correct now? You know this property, right? It's a very important property. It's a higher level property, not easy properties. Okay. So log to the base 2 of 9. This 2 into log to the base 2 of 9 of 2 can be written as, here your n is 2. Seeing these two properties, n is 2, therefore I can write this as log to the base 2 of 9 whole power log to the base is 2 of 9 of, when I take this to this side, I will get m power n. M power n will be 2 power 2. 2 power 2 is 4. 2 power 2 is 4. Then into I'm having 1 by 10 to log to the base 7 of 4. Here, your 1 by 2 is n. Therefore, I can get log to the base 7 of 4 power 1 by 2 because I am having m power n. 4 power 1 by 2 is root of 4. Root of 4 is 2 only. Therefore, I can write this as 7 power log to the base 7 of 2. Correct? Because I am taking 1 by 2 inside, therefore I will get 4 power 1 by 2. 4 power 1 by 2 is 2. I hope that makes you people clear. Very, very simple concepts. Very, very simple concepts. Okay. So now people, let me take your log to the base 2 of 9 as x. Because of log to the base 2 of 9 only this much complicated pronunciation I am making. So therefore I will take this as x. So then when I take this as x, I can write the same log as log to the base 2 of 9 is x, therefore it will be x power log to the base of log to the base 2 of 9 x of 4 into 7 into log to the base 7 of 2. This is what I will be left out. Okay, so I'll wrap this. 1 minute people. This is what I will be left out. Okay. So now what you are going to do here is, in this methodology, the thing that you guys need to understand is, when I take your log to the base 2 of 9 as x, this is what you will get, x power log to the base x of 4 into 7 power log to the base 7 of 2. So now we know in property na a power log to the base a of b can be written as b. Correct na? This is also an important property. If you don't know this property, surely you will do a mistake. I am damn sure. So now I can write this as x power log to the base x of 4. Here a is x. This will be nothing but b. What is b? 4. So 4 into 7 power log to the base 7 of 2. Here your a is 7. Hence your b is 2. So 4 into 2 is equal to 8. And that's the answer for the question. I hope you guys have enjoyed this solving. Okay. 8 is the answer for the question. So what I did is just to use this property. When took log to the base 2 of 9 as x, therefore you get x power log to the base x of 4 into 7 power log to the base 2 log to the base 7 of 2. Therefore using this property, a power log to the base a of b is b, where this a and this a are same. Hence using this x and this x are same. Therefore I can write this 4 into this 7 and this 7 are same. Therefore I can write this 4 into 2, that is your 8, and that's the answer for the question. That's all guys. I hope you guys enjoyed this question. Let us move on to the next one. The value of the integral of 3 root cos theta by root cos theta plus root sin theta whole power 5 of d theta from 0 to pi by 2. And people, this question was asked in JEE Advanced 2019. So, in JEE Advanced, calculus it's a most weightage topic. Okay, calculus is the most weightage topic, like your integration, limits and derivatives, continuity and differentiability, application of derivatives. Those parts are very important because in JEE Advanced you can expect lots of questions from that. Because nowadays the weightage has become very higher. Okay, so more than algebra, you can expect calculus part very higher. Okay, so how to solve this question is, so for this integral I am going to use your famous King's rule. So what your King's rule says is, integral of f of x dx from a to b can be written as integral of f of a plus b minus x of dx from a to b. This is what your King's rule says, right? And that is something I'm gonna apply in this integral. So using King's rule, let me take this integral as IA. So using King's rule, I can write the same I as integral of f of a plus b minus x of dx. F of a plus b minus x will be nothing but f of lower limit plus upper limit minus x, that will be f of 0 plus pi by 2 minus x. F of 0 plus pi by 2 minus x will be f of pi by 2 minus x. Hence I am supposed to find the value of f of pi by 2 minus theta. Correct now? If this is f of theta, I need to find the value of f of pi by 2 minus theta. And please remember that your variable of this integral is theta, and that is why I wrote it as theta. You may ask, why don't you write as x? Using King's rule, I am having x only. Why when you are writing as theta? Because the variable of this integral is theta. These are all basic. I can't explain these things, people. So I am saying now itself. So f of pi by 2 minus theta is something I am supposed to find using our King's rule. So now I can write the same integral as 3 into, if you need to find the value of f of pi by 2 minus theta, just put the value of theta as pi by 2 minus theta. So cos of pi by 2 minus theta is sin theta, allied angles formula. Then divided by root of cos of pi by 2 minus theta will be sin theta, allied angles. Then plus of root of sin of pi by 2 minus theta will be cos theta, again allied angles. Then whole power 5 of d theta from same limits only. Using King's rule, the limits are same only, right? So when you find the value f of pi by 2 minus theta, just put theta as pi by 2, and this is sort of integral that you guys will be left out, and allied angles formula is very important. So now let me club these two integrals. Club means add these two integrals. Hence I plus I will be 2y. Limits are same, 0 to pi by 2. When you add these two integrals, what I will be left out is 3d theta by root sin theta plus root cos theta whole power 4. This is what you will be left out. Okay, when you add these two integrals, this will be left out. How I am saying is, guys, as the limits are same, you can directly club these inside values. So you get 3 into root cos theta plus root sin theta by root sin theta plus root cos theta whole power 5. So 1 root sin theta plus root cos theta will get cancelled on both numerator and denominator. Hence I will get it as root sin theta plus root cos theta whole power 4. Very simple, just add them. Just add this up. Such a simple concept. So now people, after this is the sort of integral I got. This is your 2y is equal to integral of 3d theta divided by root of sin theta plus root cos theta whole power 4 from 0 to pi by 2. So now what I'm going to do here is, I'm going to divide by cos theta on both numerator and denominator. What I'm going to do? I'm going to divide by your cos theta on both numerator and denominator. If I divide by cos theta on both numerator and denominator, what you will get is, I can write the same 2y as divided by cos theta on both numerator and denominator. I will get it as integral of 3 into, when divided by cos theta on numerator, I will get 1 by cos theta, that will be secant square theta, then of d theta. The denominator, when divided by cos theta on your denominator, will get, I say what I am doing is correct or not, root tan theta plus 1 whole power 4 from 0 to pi by 2. This is what you will be left out, correct now? Say whatever I did is correct or not. This is what you will get when you divide your cos theta on both numerator and denominator. Okay? So now this is your 2y. Hence, what I am going to do here is I will rub these things. This is not necessary now. Okay, your 2y is this integral. This is what you will get in the cos theta on both numerator and denominator. So hence, if 2y is this value, your I will be given 1 by 2. I can take it at last. But before that, what I am going to do here is, I am going to take your tan theta as t. Substitution method. When you take your tan theta as t, then your dt will be nothing but differentiation of tan theta is the secant square theta of d theta will give us dt. Correct now? Correct now? This is the substitution I am going to apply in this integral. When I apply, I can write the same integral 2y as 2y is equal to integral of 3 into secant square d theta. So if secant square d theta is dt, I can write as 3 dt, correct na? 3 dt divided by root of t. Correct or not? Guys, wait, I did a mistake. Wait. I did a mistake, okay? You are not going to take tan theta as t. Wait. You are going to take tan theta as t square. Okay? That's a mistake. Don't do this mistake. I'm going to take your tan theta as t square. When you take your tan theta as t square, your dt will be secant square theta of d theta. That will be, I will rub this itself because I did a mistake na. I will say what I did here. I need to take your tan theta as t square. Then if I take your tan theta as g square, differentiation of both sides, so 2 d theta will be equal to secant square theta of d theta. Correct na? Correct allaya? Correct na? So this is the substitution I'm gonna use here. When you take your tan theta as t square, then secant square theta of d theta will be your 2t of dt. So I can write the same 2y as integral of 3 into secant square theta of d theta, that will be 3 into 2t. 3 into 2t dt, correct? Then divided by root of tan theta. If tan theta is t square, root of t square will be t plus 1 whole power 4. Now what will be the limits? The limits will be same. Will the limits be same as 0 to pi by 2? Of course not. Of course not. Whenever you substitution, the limits will change. It depends upon the substitution. For example, if you take your tan theta as t square, your limits will take upon the value of t. Your limits will take upon the value of t. So how you will do is, when you consider the lower limit, put your theta as 0. When the lower limit having 0 now, so put your theta as 0, therefore you will get tan of 0. Tan of 0, any it will be 0 only. So t value will be root of 0, that is 0 only. When you consider the upper limit having pi by 2, hence tan of pi by 2 is infinity. Again root of infinity, it will be infinity only. Correct? This is how we are. This is a methodology by which you should change the limits. Okay? So when you consider the lower limit, put theta as 0, then you will get a t value of 0. When you consider the upper limit, put theta as pi by 2, then your t value will be infinity. That's all. Okay? So now I will rub these things. Hence, I can cancel these two 2's now. 2 can cancel. Therefore, I will get the I as, I'll take the 3 outside. 3 into integral of t dt by t plus 1 power 4 from 0 to infinity. This is what I got now. So this is the value of I am having now. Now I need to do some simplifications and therefore I can get the answer easily. So what I'm going to do here is, in the numerator, I'm going to add 1 and subtract 1. Therefore the same I can be written as integral of 3 into integral of, I'm going to add 1 and subtract 1, that will get t plus 1 minus 1 by 1 plus t power 4 of dt from 0 to infinity. This is what you will get, right? This is something, a type of integral that you guys will be left out when you add your 1 and subtract 1 in your numerator. Correct na? Correct na? So now what is the need of adding and subtracting 1? You guys will have doubt on it. So why I am doing that is, listen, if I do like that, can't I write this integral as splitting method, guys? I hope you know that. You can also use your partial fractions, but here I am using like this. So 3 into what? 3 into integral of, I can split it as, take this t plus 1 as one term. That will get t plus 1 by 1 plus t power 4 minus a 1 by 1 plus t power 4. That will be nothing. But t plus 1 by 1 plus t power 4 will be 1 by t plus 1 the whole cube. Correct? Okay. Then minus 1 by 1 plus t power 4. Correct? then of dt from 0 to infinity. This is what you guys will be left out. This is what you guys will be left out. So now what you will do? Tell me people. Now what you will do? I got your I as this value. So now you are supposed to integrate. So integration, I hope you guys know that. Okay, so when I integrate, I can write the same I as 3 into minus 1 by 2 into 1. What you will get? Think and say. I think 2 into 1 plus t square, right? 1 plus t square. I will rub this. This is not important now. So 1 plus t square, then minus of, minus what? Minus of, oh, it's difficult people. Minus of, okay, minus of minus 1 by 3 into 1 plus t cube. I think this is what you will be left out. Okay, check and say I is equal to 3 into minus 1 by 2 into 1 plus t square, then minus of minus 1 by 3 into 1 plus t cube. Okay, and the limits are from 0 to infinity. So now the question is very simple, na? Just you're supposed to solve it up. So minus into minus is plus. Okay, so therefore minus into minus is plus, therefore I can change this as plus. Okay, so plus, this is what you will be left. Now when you solve the limits part, first put t as 0, t as infinity. When you put t as infinity, you will get 0. Okay, now when you put 0 in place of t, I will get minus 1 by 2. Because when you put 0 in place of t, minus 1 by 2 into 1 plus 0 whole square, that will be 1 square. So minus 1 by 2. Then plus of 1 by 3 into 1 plus t cube. Put 0, t as 0, you will get 1 by 3. Correct? This is how you guys will be left. This is what you guys will left out. So hence the answer will be 0 plus 1 by 2 minus 1 by 3. 0 plus 1 by 2 minus 1 by 3 will be what? Will be 3 by 6 minus 2 by 6, that will be 1 by 6, and that's the answer for the question. Correct or not? Hey, did I miss any mistake? So therefore plus 0 1 by 3. Okay, plus 1 by 2. So this will be 3 by 6 now. So 3 by 6 minus 2 by 6. Okay, no, this is not answer. 1 by 2 is the answer. And that is equal to 0.5. Okay, 1 by 2 is the answer for the question. Just solve it up. And this is also wrong, I think so. So 1 by 2 will be the answer for the question. Let's solve it, guys. Solving, you know, na. But for this question, the 1 by 2 is answer. Everything I did is correct. Everything I did is correct only. Hey people, wait. Sorry. You got it as 0 minus of minus 1 by 2 plus 1 by 3, correct na? Now I add 3 here. We missed out that t, that is why I think we did it wrongly. So 3 into 0 plus 1 by 2 minus 1 by 2. 0 plus 1 by 2 minus 1 by 3 will be 1 by 6. So 3 into 1 by 6 is 1 by 2, that's your 0.5, that's all. Okay, sorry for that mistake, I forgot the 3. That's all, guys. Let us move on to the next one. Next question is, let a comma b comma c be positive integers such that p by a is an integer if a comma b comma c are in GP and arithmetic mean of a comma b comma c is b plus c, then find the value of a square plus a minus 14 by a plus 1. And this is the JEE Advanced 2014 question. I didn't mention it anywhere. This is JEE Advanced 2014 question. And don't expect this sort of question current year. Okay. You can't expect this side of dumb question. I don't say it's a dumb question, easy level of question in the upcoming year. You can't expect, but anyway, it's a good level. I can't say it's a dumb question, people. I can say it's a good level of one. So let's solve it. And they are given that ABC are positive integer and ABC are in GP. And also it's given that arithmetic mean of A, B, C is B plus C. That means, guys, this is not B plus C, it's B plus 2, I think so. This is B plus 2, sorry, it's B plus 2. So now, if arithmetic mean of A plus B plus C, A, B, C is B plus C, B plus 2, then I will say that your A plus B plus C by 3 is equal to B plus 2. Correct now? This is what I can conclude, right? Very simple. Arithmetic means sum of all the observations, number of observations, and that is given as B plus 2. So A plus B plus C by 3 is equal to B plus 2, and also it is given that A, B, C are in GP. If they are GP, the general form will be nothing but A, AR square all the way up to AR to the power of n minus 1, where AR to the power of n minus 1 is the general term. But this is the general sequence, how it looks. So therefore, let me take your first term as A, second term as AR, and third term as AR square, where R is the common ratio. Okay? So when I take like that, I will get as A plus AR plus AR square by 3 will give us B plus 2. What is B? That is AR plus 2. So now take the 3 that side, therefore we'll get us A plus AR plus AR square will be equal to 3AR plus 6. Correct? Now take this 3AR to this side, therefore I will get it as A. When I take this 3AR to this side, I will get 3 minus 2AR plus AR square. Correct? And that will be equal to 6. This is what you will get when you take this 3AR to this side. Therefore, you get AR minus 3AR will be minus 2AR. That's all. So now people take your A common, therefore you get it as 1 minus 2R plus R square, and that is equal to 6. This is a form of equation that will be left out when you take your A common. After this, think carefully and say A into what is this 1 minus 2R plus R square? That is nothing but your R minus 1 whole square. That's nothing but your R minus whole square, and that is given as 6. If A into R minus 1 whole square is equal to 6, then your A will be 6 by R minus 1 whole square. Correct now? Guys, I am solving very fast because it's an easy one. Okay, you can't expect this type of easy type of question in advance. But even though, try to solve it. Okay, even though, try to solve it. Therefore, A is equal to 6 by R minus 1 whole square, and it is given that A, B, C are positive integer. This clue is very important for this question. Okay, if without this clue, you can't solve this up. Okay, that's what we say. The matter how you guys use the clue, how you guys approach it is such important, and please follow that very carefully. Okay, so now they are given A, B, C are positive integer, and we know that your A is your first integer. So this here and this here same. Hence, this A should also be positive, and we know that your R is common ratio. If your all the terms of the GP is positive, then of course R should also be positive. You can understand now. If all the terms of GP are positive, then of course your common ratio should also be positive. For example, we know that your form is A, AR, AR square. Here I am saying that your first term is positive. Then if I put R as minus some negative value, you will get A into negative value. That will be negative value. Then all the integers will not be a positive one. So if all the values, all the integers, all the numbers of your geometric progression are positive, then of course your common ratio is also positive. So this shows that A is also positive, R is also positive. So I can take upon the value of natural numbers more than 0. Okay. So now, because if I put 0, you will get 6 by 0 minus 1, that is minus 1, 6 by 1 is 6. So that's also correct. So what I want to do here is, first let me put your R as 1. Let's put your R as 1. Then you will get your A as 0. When you put a r as well, 6 by 1 minus 1 whole square, 6 by 0 square, that will be 0. Not 0 guys, 6 by 0 is not defined, infinity. Will tend to infinity. That is not good. When you put your r as 2, I will get your a as 6. This is absolutely fine, okay? If you put r as 2, if you are getting a as 6, is absolutely fine. This is not at all good. But this is absolutely fine. Now when you put your r as 3, you will get a is equal to what? A is equal to 6 by 3 minus 2, so that will be 6 by 4, that will be 3 by 2. 3 by 2 is an integer? Nope. You put your r as 4, I will get your a as 2 by 3, correct? Correct or not? Correct. So a is equal to 2 by 3, is 2 by 3 is an integer? Of course not. So if you keep on doing like this, r is equal to 5, r is equal to 6, r is equal to 7, it will be, you will be doing for next night. Up to next night you can do that. But guys, please understand, after 2, every value of r gives a non-integer value of a. You can conclude that now. After 2, every value of r will give a non-integer value of a. That's what you can conclude. So this shows that your a must be 6. If a is 6, then a square plus a minus 14 by a plus 1 will give 28 by 7, that is equal to 4, and that's the answer for the question. That's the answer for the question. Okay. So after 2, every value of r will give a non-integer value of a. That is why your a must be 6. If a is 6 square plus 6 minus 14 by 6 plus 1 will be 28 by 7, that is equal to 4, and that's the answer for the question. That's all guys. I hope you guys will enjoy all the questions that we solved today. All the questions I solved are very good questions and advanced. All the questions I picked were JEE Advanced PYQ. Except this, everyone are recent year. Like 2019, 2020, 2021. So I hope you guys enjoyed it. That's all. Please share the video guys, because I'm hard working a lot to do this video. Because doing JEE mains is not all easy, but advanced. Okay, I'm almost doing this for 3 hours. 3 to 4 hours. So okay, that's all guys. Thank you. Make education simple.